The last question on our practice test A. When 50 grams of silicon dioxide is SiO2 heated with an excess of carbon, the reactant here as C, carbon, 32.2 grams of silicon carbide are produced. Silicon carbide is SiC. The blanks here are reminding us to check to see if it's balanced. Let's begin with that before we worry about any stoichiometry. We'll do some counting. I'm counting 1 unit of Si on both sides. That looks fine. 2 units of O on the left, but there's only 1 on the right. I'll need to double. No, I don't. Let's see. That gives me, oh yeah, I do. Si, 1, 2 oxygens. Oh yeah. And now I'm counting the carbons. 2 units of carbon plus 1 more. I'll need a 3 in front of that carbon. Let me check once again. It's late in the day. 1 silicon, check. 2 O's, oh yeah. 1, 2, 3 carbons. 1, 2, 3 carbons. I believe I'm balanced. If 50 grams of silicon dioxide is heated, we make 32.2 grams of silicon carbide. This will be known as our actual yield. We didn't perform the experiment. We need to be told the experimental value. We'll calculate the percent yield of our reaction. The given was the amount of reactant, 50 grams of silicon dioxide. We'll set up our 3 parentheses where we target SiC, silicon carbide. The actual yield information was given for SiC. That makes this our want. The want is known as our theoretical value. We can compare theoretical to the actual and measure the efficiency of our reaction. We'll need a molar mass in our first conversion. Let me find silicon, number 14. Its mass we'll call 28. 28 plus 16 times 2 gives me a molar mass of 60 grams of SiO2. 1 mole of silicon dioxide over 60 grams. We're in the heart of our problem. We want over given. The coefficient of 1, SiC, gets placed on the top, set over the coefficient of 1 for the SiO2. The want over given is a 1-to-1 ratio. Noticing we need to go to grams of SiC. Again, I gotta find Si, forgot. 28 is its molar mass, plus the carbon. So 28 adding 12 gives me a molar mass of 40 grams of SiC set over 1 mole of SiC. Let's hit 50, divide by 60, times 40. I'm finding 33.3 grams of SiC. The measure is called the theoretical yield. Now to calculate the percent, we find the actual 32.2 grams set over what we just solved for, 33.3 grams, and express that as a percent as a measure of the efficiency known as the percent yield. 32.2 divided by 33.3 times 100. This equation had a 96.6% yield. 96.6% taking actual over theoretical as a percent. Now, in the same question, we're being asked to calculate how many grams of carbon monoxide would have been made. Starting the same journey with 50 grams of SiO2, we'd like to know how much carbon monoxide was made. in a gram unit. So if I'm targeting grams of CO, we'll have the same first step, 1 mole of silicon dioxide said over 60 grams of SiO2. But we have a new target. The target is now CO. In its coefficient placed on the top is a 2. Set over the 1 mole of SiO2, the given. Want over given ratio is 2 over 1. We'll now need a molar mass of CO. Carbon is 12, 16 on the oxygen, gives me 28 grams for every 1 mole of CO. However, this reaction is only 96.6% efficient. I'm not going to produce 100% of this value, but only 96.6%. And percent means parts out of 100 parts. I am going to account for the efficiency of this equation in a last parenthesis. I'm only going to take 96.6% of my theoretical yield. So I'll take 50 over 60 times 2 times 28 times 0.966. I have produced 45.08 grams of CO as my actual yield. 45.08 grams, the actual yield, with the efficiency of 96.6% playing a role in this equation.